Good day and greetings. Today, I will present our project entitled Insulated Wall Panel using Bamboo Fiber, with a theme Sustainable Bamboo Materials for Modern Construction, Building the Future with Nature. This project supports the initiative Kita Bestari, TVET at KKDW Lestari.
This project is prepared by Mr. Cyril Nizam, Nerfate Namera, and Amelia Natassia.
The construction industry is one of the major contributors to carbon emissions. Most wall materials absorb a large amount of heat, especially in hot climates like Malaysia. This causes buildings to become uncomfortable and also increases fire risk. Therefore, more sustainable and safer wall materials are needed for modern buildings.
Bamboo is a fast-growing and renewable natural material. Bamboo fiber is lightweight, strong, and has good thermal insulation properties. Because of these advantages, bamboo fiber is suitable to be used in insulated wall panels as a sustainable building material.
In current buildings, walls absorb a high amount of heat, which reduces indoor comfort. Fire risk is also increasing, especially in hot environments. Most conventional wall panels are less sustainable and not environmentally friendly. Therefore, there is a need to develop a better and greener wall panel.
The objectives of this project are to evaluate the fire resistance and heat transfer of bamboo fiber wall panels, to compare them with conventional wall panels, and to develop an insulated wall panel using bamboo fiber.
This project was conducted at College Kemahiran Tinggi Mara Sri Gading. The bamboo fiber content used was 3%, 5%, and 10%. The panel size was 100 x 100 x 12 mm. The testing standards used were ASTM E119 and ASTM E84.
The materials used were cement, sand, bamboo fiber, and water. The water-cement ratio was 0.4. Bamboo fiber was used to replace part of the sand in the mixture.
The methodology consists of 3 steps: bamboo fiber preparation, panel casting and curing, and fire and heat testing. Panels with 3%, 5%, and 10% bamboo fiber were produced and tested to compare their performance.
A torch burner was used to expose the panels to fire for 15 minutes. The temperature on the front and back surfaces of the panel was measured to evaluate heat transfer and fire resistance. The tools used were a thermal imager, Testo 868, and an infrared thermometer, Fluke 64 Max, to record the surface temperatures during the test.
The results show that panels with less bamboo fiber become hotter, while panels with more bamboo fiber stay cooler. The 10% bamboo fiber panel has the lowest temperature, which means it provides the best insulation and reduces heat from passing through the wall. This slide shows the fire spread results. The panel with 3% bamboo fiber has the largest fire spread, while the panel with 10% bamboo fiber shows the smallest fire spread. This means higher bamboo fiber content helps reduce fire spread. All samples are classified as Class A based on ASTM E84.
As you can see from this comparison, our bamboo fiber panels outperform both traditional plywood and cement boards. Our key advantages are twofold: superior insulation and equal or better fire resistance. This makes our material a safer and more energy-efficient alternative for modern construction.
In conclusion, bamboo fiber improves both the fire and thermal performance of wall panels. Higher bamboo fiber content gives better results. Among all samples, 10% bamboo fiber performed the best.
For future work, the durability and water resistance of the panels should be improved. Further testing should also be done for real building applications.
Thank you for listening to our presentation. Kita Bestari, TVET at KKDW Lestari.